In this video, we are going to do these 4 questions from the chapter Polynomials class 10th. And we have taken one assertion reasoning. There is an MCQ. And these 2 questions are of 3 marks, can be asked in 2 or 3 marks. So let's begin with the first question. In this question, the assertion says that x cubed plus 1 has only 1 0, right? And the reason is a polynomial of nth degree must have n zeros. So let's figure out the assertion first. They say that this polynomial has only 1 0. So if we factorize this polynomial, that is x cubed plus 1, x. So we can take x common, so that will result to give you x squared plus 1. Now, if I equate this factor with 0, we get 0 as one of the polynomial. Now, equating the other factor with the 0, what do you get? You get x squared as minus 1. As you know, square of a number cannot be negative. So we'll say that this does not have any 0, right? This does not have any 0. So yes, we got to know that this cubic polynomial has 1 0, right? That is 0 can be the 0 of a polynomial. So we can say assertion is correct. It says it has only 1 real zeros. Now, when I read the reason, it says a polynomial of nth degree must have n zeros. That's not true. You can see that this is a polynomial with degree 3, but it does not have 3 zeros. It has only 1 0. So this reason is correct. In fact, we should know that any polynomial with degree as say 3 will have at most 3 zeros, maximum 3 zeros. Similarly, a quadratic polynomial, if I write any quadratic polynomial, it can have maximum 2 zeros. So when they say that the nth degree, that means it can have up to 3 zeros, right? So therefore, we say that assertion is correct, but assertion is correct over here, and the reason is false. In this MCQ, it says a quadratic polynomial whose zeros are what? Minus 3 and 4. And what we have to figure out that which of them is the correct polynomial. So what you can do here, that you can find the first sum of the zeros. And what is the sum of the zeros here? Minus 3 plus 4. That is minus 3 plus 4 is how much? 1. And if I find the product of the zeros, what we are going to get? Product of minus 3 and 4 should result to give you minus 12. Now, what is the general formula for framing a polynomial? This is x squared minus the sum of the zeros times x plus the product of the zeros. Now, let's say if I plug in sum as what? Sum is 1 over here. And this minus sign is because of the formula. So this is minus x minus 1x, right? And plus the product of the zeros, but here the product is negative 12, so I should write minus 12. Now, many of you actually select this as the correct answer, or sometimes this also, because you don't see the sign. So we can see that this is clearly not true, because here C is positive, RC is negative, right? So is the reason for this also. Now, when I come to the next part, that is this one, let's say, you may see over here that again the sign is B should be negative, and we have B as what? B should be negative, but here B is positive. Now, therefore, the C part must be correct, but let's figure out. So now, why C should be correct? For that, what we are going to do, let's say if I write down this C part, which is x square over 2 minus x over 2 minus 6. Now check, if I take LCM over here, 2 is the LCM. That will give you what? X squared minus x minus 12. I can keep half outside, that results to give you x squared minus x minus 12. Now, what you can see from here, that keeping k as half, this is same as this. So therefore, C is the correct option for this. Now, in this question, what we are given, that alpha and beta are the zeros of this polynomial, such that alpha minus beta is minus 6, and what we have to get is the value of k. Now check here, we are given a difference of the zeros. And since the polynomial is known to us, what we can find the sum of the zeros. So what is the sum of the zeros? That is alpha plus beta. That is how much? Minus b by a. Minus, that means negative coefficient of b. So minus of minus minus of minus 5 is what? Positive 5 minus b over a, and a is what? 6. So we got one relation of alpha and beta, and other is already given, that we can write alpha minus beta as how much? Alpha minus beta as 1 over 6. Now we are going to add this equation. You can see on adding beta and beta get cancelled, and alpha plus alpha, that is 2 alpha. With the same denominator, if we add, what you'll get? 5 plus 1, 6 over 6, and that is 1. So now I can say alpha is what? 1 over 2. Now if you know the value of alpha, you can get beta. In order to get k, we need beta. Yeah. So what I'm going to do is to replace the value of alpha in any of these equations. Say I do in the first part, replacing alpha with half. Beta is what we have to get. Oh, that is equal to 5 over 6. Now beta will be what? That is 5 over 6 minus half. So therefore the LCM is what? 6 over here. 5, this is 5 1 times, and 3 times is 6. So 3 into 1 is 3 over. So we got beta as how much? Beta we got as 2 over 6. That can be reduced to be written as 1 over 3. Now check, we got the value of alpha and beta, but then now what we'll do is to get the value of k here. Now to get k in this case, we'll obtain the product of the 0. Product of the 0, that is alpha into beta, is what? C by a. Well, c is the constant and a is 6 in this case. So we can say this is k over 6. Next, we are going to replace the values of alpha and beta. Here, alpha can be replaced with 1 over 2, and beta in this case can be replaced with 1 over 3 is equal to k over 6. Now this is what? 1 over 6 is equal to k over 6. So we can cancel like this, and to obtain k as what? 1. So 1 is the value of k in this case. In the next question, it says beta and 1 over beta are the zeros of this polynomial. So clearly 1 0 is reciprocal the other. And what we have to find out is the values of beta and alpha. So you should know that the product of the zeros, like zeros are this, right? So if I find the product of the zeros, here zeros are beta and the other 0 is 1 over beta. And what is product of the zeros? It is c over a, and a is this whole thing, right? The coefficient. This whole thing is a. So I can replace this. I can write this as 6a. This is c over a, and a is what? A square plus a. So here these two beta and beta get cancelled. So we have 1, and by cross multiplication, what we'll get? We'll get a square plus a, like this is 1, right? So a square, 1 multiplied by a square plus a is equal to 6. Right, so what I did over here, I found the product of the zeros, which is c by a, and then equated with product. And now by cross multiplication, we are getting 6 a square plus a is equal to 6a. That means a square is what? A square is 5a. Or it's better to write down like this. You should write a square minus 5a is equal to 0. So taking a as common, we get a minus 5 equals 0. So a can take two values, that is a is equal to 0 or a is equal to 5. Now what we have to get is the value of beta and alpha, right? So that is beta and alpha are what? These are the zeros, right? Where they should have mentioned, they haven't mentioned what is alpha stands for, but by default it has to be the zeros only. Or could be the value of a also, we can't predict, could be some printing error. As of now, I'm considering that we have to obtain the zeros. So what we are going to do is to write this polynomial again by placing alpha as a as 0. Now check, if I replace wherever there is a as 0, what do we get? We'll get this as 0. So placing this as 0, yeah, this is important to understand. Placing a as 0, we get 0 times x square. We get 0 times x square plus 61x, right? plus 0. As you know that for a quadratic polynomial, it's in the form of ax square plus bx plus c. A should not be 0, right? So we should discard this value, providing the reason why this is discarded. Now, considering the other value of a, which is 5 here, so I'm going to replace a with 5. So 5 square is 25 plus 5 times x square plus 61x, and then again replacing this a with 5. So 6 times 5 is how much? 30. Right. So 6 into 5 is 30, and 5 square plus 5 is also 30. So that results to give you what? 30x square plus 61x plus 30. Now we are going to factorize this by middle term factorization. So we are going to do middle term factorization over here. So that is 30 into 30 is what? 900, right? From the factors of 900, we have to obtain 61. So if I go by 2, this is 450. This will give you 450. Continue factorizing by 2, we are getting 2 to 5. By 3, it is 75. Let's check here, 75, and this is 12. 75 minus 12 is 61. No, but wait, because we have all positive here, so this factor will not work. Continuing factorizing with 3, it is how much? 25. This is how much? 36 and 25. Yes, 36 and 25 on adding we get 61. 30. What was that? 25 and 36. So this can be written as 30x square plus, I can write 36x and plus 25x plus 30. Right. We got this, and now we are going to factorize, split it. We have split it. Now we are going to take common. So on taking what is common between the first two terms, that is 6 is common. So 6x is common. In fact, this is 5 times x and then 6. From last two term, 5 is common. Taking 5 as common, we get 5 into 5, 25. So 25x plus 6. So this is 5x plus 6, and this is 6x plus 5. Right, equating this with 0, we'll get what? Minus 6 over 5, and equating the other part as 0, we are getting minus 5 over 6. Yeah, that's right also, because you can see from here that the zeros are reciprocal of each other. So the two zeros, in case if you have to find two zeros, we'll say that minus 6 by 5 and minus 5 by 6 are the two zeros.